Hi guys, hope you all preparing well for upcoming chemistry competitive examinations. So here we are going to analyze a standard model problem which was picked up from photochemistry part 1 online exam conducted on test series of chemmasters.online. If you are interested, you can visit and join on chemmasters.online to practice high standard online test series along with conceptual courses to boost your success rate. Okay, now just come to the point of question. The major product in the following reaction is, here we have given with a carbonyl reactant under photochemical conditions. What is the product? Okay, right. We need to look at gamma hydrogens. If the given carbonyl reactant having gamma hydrogens, so where we should start to give or to label the carbons. So from the adjacent carbon of carbonyl group, just to give the labelings alpha, beta and gamma. Here on gamma we have hydrogens. So whenever gamma hydrogen is having hydrogens with respect to that carbonyl group under photochemical conditions, it always produces the product of Norrish type 2 reaction. So here most of the students simply find this. The reaction is taking place through the Norrish type 2 mechanism. But most of the aspirants fail to give or fail to choose the correct answer here. Okay, so we can see how and why, right? Yeah. So now try to check the general Norrish type 2 reaction here, alpha, beta and gamma. Here we are representing one hydrogen. Under photochemical conditions, the carbonyl group excites and produces radical, oxygen radical here, okay, and carbon radical. Now, in the next step, the hydrogen or the gamma hydrogen cleaves as radical and which is abstracted by this oxygen radical. Okay, now in that sense, here is a formation of OH and there is a new radical, that is gamma carbon with radical formation. Okay, right. In the next step, alpha here, this is alpha. Okay, the bond between the sigma bond between alpha and beta carbon cleaves to produce the major products of Norrish type 2, enol and ene. Okay, this is the general mechanism of Norrish type 2 reaction. If this is the case, then first answer should be the correct one, but it is not. Why? Because here there is a question for you. Why alpha and beta bond or sigma bond easily cleaves in Norrish type 2 reactions? Can you give the explanation for it? Yeah, so just wait for it. pH, so just draw here. Okay, right. Now, the carbonyl group, or just say here, just represent carbonyl group with its orbitals. Okay, now here is a sigma bond. Just represent with its pi bonds or its loops. Just say, okay, now gamma carbon with its lobes. So sigma bond always forms whenever the same kind of lobes are interacted, right? And here you can see sigma bond, that is between alpha and beta bond, sigma bond easily cleaves because a strong partial pi interaction is observed here. So due to that, it produces pH, OH here, and here is a double bond. That means a strong partial interaction, pi interaction makes a strong bond here, pi bond here, that simply leads to the breakage of the sigma bond. And here for this alkene, also strong partial pi interaction leads to produce this alkene. So that's why alpha beta bond in Norrish type 2 easily cleaves. And this only happen whenever all these carbons, that is carbonyl carbon, alpha, beta, gamma, or if all these carbons are on same plane, it will happen to produce these products as major products. Okay, now, but whenever the alpha carbon, here just say, whenever the alpha carbon is having bulk substituents, so here we have C double bond O, here we have two methyl groups. Okay, in the reactant we have two methyl groups. So we can say alpha, beta and gamma. Whenever alpha carbon is having bulk groups, we can see steric repulsions absorbed between the phenyl group and these methyl groups. So whenever steric repulsions are observed, there will be no plenarity between carbonyl carbon, alpha, beta and gamma carbons. So the deviation can be seen. Okay, right. Now just represent with lobes here. Just do the same thing. pH, and this is carbonyl carbon orbital lobes. Okay, and here alpha, beta, and this is gamma. So due to the presence of bulk methyl groups, steric repulsions can be seen between phenyl and methyl group. So the plenarity disturbed. Due to the disturbed plenarity, there is no perfect orbital interaction between these side loops, or so there is no possibility to make partial pi interaction because there is no plenarity for this carbonyl alpha, beta, gamma carbons. Why? Because of steric repulsions which are absorbed between phenyl group of that carbonyl and the bulk substituents at alpha carbon. Okay, so due to this, simply the interaction between carbonyl carbon lobes with gamma carbon lobes is more possible, and there is a formation of new sigma bond. That means there is no alpha beta bond breakage, but there is the possibility to produce a new sigma bond between carbonyl carbon and gamma carbon. Okay, so the deviation increases the interaction between carbonyl carbon and gamma carbon, so produces a cyclobutane derivative. Okay, so here we have CH3, here we have pH, here we have OH. So which is the correct answer? Second option is the correct one. Okay, here we are not going to produce a normal Norrish type 2 product which is absorbed whenever the alpha carbon is free from the steric repulsions. Whenever alpha carbon is with bulk substituents, then the normal or general Norrish type 2 product is not possible, but a cyclobutane derivative will be produced. Okay, so option 2 is the correct one. Thank you very much. If you like this video, please click on like, share and subscribe the channel for more updates. And if you interested further, visit chemmasters.online to get best conceptual chemistry courses and practice high standard online test series and get huge success in your examination. Thank you very much.